a very good morning to you from Mission Control Houston. The reason we're here, right there on your screen. SpaceX's Dragon getting ready to depart from the International Space Station. It sits poised at the end of the Canadarm2 robotic arm, packed with over 4,100 pounds of science experiments, hardware, and other cargo from on board the International Space Station, just a few hours from splashing down in the Pacific Ocean after a very successful mission for one of NASA's two commercial cargo providers. Good morning, I'm NASA's Dan Hewitt, and we are joined here in the Mission Control Center in the Johnson Space Center in Houston, Texas, and we'll be bringing you live coverage as we get ready to say farewell to Dragon, the 11th Dragon, to visit the International Space Station. Here inside the room, the teams overseeing all the various systems on board the orbiting laboratory. They are led by Flight Director Dina Cantella, and she'll be leading the teams throughout all of the operations today. Again, Dragon already poised on the end of the robotic arm. It was detached from the Harmony module just earlier on Sunday. It is now officially Saturday or Monday, so I will try to keep the dates in order here, as it is 1 a.m. Central Time here in Houston. But Dragon detached from the Harmony module in the mid-afternoon, around 1:30 p.m. local time here in Houston. The Dragon had been attached there for several weeks since a successful launch from Florida and a flight up to the International Space Station, but it was detached and moved into its release attitude by flight controllers down here on the ground. The hatch had actually been closed back on Saturday afternoon, so a little more than 24 hours later, Dragon was detached and moved into where it sits now. You can see it with the Earth passing by in the background. The station and Dragon obviously just passed over the northern border of Spain, about to swing out over France and through Central Europe as it orbits the Earth at about 253 statute miles, traveling at over 17,500 miles an hour. The sun just came up on the Expedition 50 crew, who just woke up a short time ago with the release of Dragon, their first task, obviously, for the day. And on board right now, again, Expedition 52 crew, they're led by Russian cosmonaut Fyodor Yurchikhin, and then two NASA astronauts also on board, Jack Fisher and Peggy Whitson. The pair are going to be in the space station's cupola module, the bay window giving them a 360-degree view of the Earth below and of visiting spacecraft like Dragon. And they'll be at the robotic workstation, Jack Fisher Prime, so his hand will be on the trigger, and he'll be the one sending the release command to the robotic arm that will ultimately send Dragon on its way. That release is scheduled to come at 1:41 a.m. Central Time today, so we do have some time to get some more views of Dragon and just enjoy it a little while longer before it says farewell and makes its way back down towards Earth. Again, Dragon capable of re-entry, the only cargo ship capable of returning cargo right now in the fleet of vehicles going to and from the International Space Station. And that's why it's packed again with over 4,100 pounds of supplies today. Of that, a little over 1,400 pounds of utilization, so science hardware, so samples and other pieces of equipment from different research experiments conducted on board the International Space Station, and these research experiments coming from all space agencies around the globe, not just NASA, but our international partners, the Japan Aerospace Exploration Agency, the European Space Agency, and the Canadian Space Agency. And then in the NASA contingent, a lot of NASA experiments, but also a lot of experiments flown on board the International Space Station through the U.S. National Laboratory, these coming from academia and commercial sectors, as well as other government agencies, to take advantage of the microgravity laboratory, the only place you can really do this kind of research, with taking gravity out of the equation, learning all sorts of new things about different processes, and we'll go into some of the research returning in just a little bit. But also in that 4,100 pounds, a lot of vehicle hardware, so just various pieces of space station hardware ready to come home, either for repair or analysis. A little under 1,400 pounds, 1,388 pounds to be exact. Also some spacewalking hardware, some crew supplies, and some computer resources on board as well. And just about 6 hours almost exactly after Dragon is released today. It'll be splashing down in the Pacific Ocean, just about 260 miles southwest of California, where teams from SpaceX will be standing by to pluck Dragon out of the water, put it on a boat, and tow it back into harbor. It'll get back, and then they'll immediately begin unloading some of the hardware. Some of those experiment samples have a finite clock on them to get them back to labs here back on planet Earth to resume the analysis. The experiments again taking place on board the station, returning and within 48 hours back in the hands of researchers back down here on the ground as for the science to continue. And again, that release time today, 1:41 a.m. Central, 2:41 a.m. Eastern Time. Should have plenty of sunlight over the next 40 minutes or so should have some good views of Dragon as it departs. Following its release, it'll drift for a few moments, and then it'll execute a series of 3 different burns, so firings of engines on the Dragon vehicle, and that'll move it away from the International Space Station, eventually getting out of what's known as the keep-out sphere and then the approach ellipsoid. These are imaginary areas around the station, defined distances, where interaction between the teams here in Houston and the teams at SpaceX out at Hawthorne, California are coordinating, and those distances are in place for any vehicle visiting the International Space Station. Once it's out of the approach ellipsoid, the teams no longer interacting on a second-by-second basis, if you will, and then the team in Hawthorne fully in control and sending Dragon on its way again for that splashdown about 6 hours later. That splashdown at 7:41 a.m. Central Time, 8:41 a.m. Eastern. That'll be 5:41 a.m. in the morning over on the West Coast. For now, though, the teams here going through all their final checkouts. They'll do a final go-no-go with Dina Kotelik polling the team, and then they'll pass on that final go or no-go to the crew on board. Again, NASA's Jack Fisher and Peggy Whitson are going to be in the cupola. Jack Fisher, his hands on the controls. He'll be the prime today to send the command to send Dragon on its way. So again, this is the end of Dragon's successful mission. It launched back in early June on Saturday, June 3rd at 4:07 p.m. Central Time, launching, of course, on SpaceX's Falcon 9 rocket from Launch Complex 39A at NASA's Kennedy Space Center in Florida. The several-minute ride into orbit on top of the Falcon 9 delivered Dragon into its preliminary orbit, and then it had about a 2-day flight to the International Space Station, and it carried over 6,000 pounds of supplies to the orbiting laboratory, and that included a lot of research and vehicle hardware inside the pressurized, which you can see just at the very top of the rocket there, which is currently attached to the robotic arm right now, but also several thousand pounds of unpressurized cargo, which we can also go into in just a little bit. But again, that launch happening back in June, 2-day flight to the station. It was captured successfully on June 5th, and then it had been attached ever since. And then the release day will wrap up about a 1-month stay, again with a little over 4,100 pounds of cargo on board.
6:40 GMT. Close at 07:05 GMT. And just for your essay, sunset is at 0650, but that has no impact to your release window.
Okay, copy. Our window is 0640 to 0705, and we're go for step 1 of 1.320, Dragon release.
You got it right, Peggy.
Expedition 52 flight engineer Peggy Whitson getting some words from the Capcom here in Houston. So just to explain that a little bit, their release window, that's when essentially the conditions are right that the crew could give the command to release Dragon. That'll open up at 1:40 a.m. Central Time. Once that release window is open, they can essentially execute that release at any time. Once the command is sent, it does take a little bit of time for Dragon to actually separate, as a series of hooks and snares inside of the robotic arm have to retract to basically let go of Dragon. The release expected to come at about 1:41 a.m. Central Time, so just 30 minutes from right now. And then Dragon will float away and then execute that series of burns. Now that release window will close at 2:05 a.m. Central Time. And so what that means is if Dragon hasn't been released by that point, they'll stand down, and then they have a backup release window where basically they'll wait about one orbit of the Earth, so they'll wait about 90 minutes, a little less in this case, and then the conditions will once again be right for the release, and then they'll be able to give it another go. That just to protect for any off-nominal, as we like to call it, but any out-of-the-ordinary situations, any issues with either the spacecraft or the robotic arm itself, everything, always having a backup plan. But the primary release window opening up in just a little while at 1:40 a.m. Central Time, 2:40 a.m. Eastern Time. And again, that release expected to come at just about 1:41 a.m. And again, Dragon returning a lot of science experiments today, but it also delivered a lot. And some of those are staying on board the International Space Station. Some that I'd just like to highlight real quick are some of the ones that rode up in the unpressurized section of Dragon, as we like to call it, the trunk. But these are extracted and installed on the outside of the International Space Station. And then they remain there either for the duration of the experiments or for the duration of their lifetime on orbit, as is the case with two of them. Over 2,000 pounds in weight of that initial launch load of over 6,000 pounds. One of those, which was installed, again, all of these operations were done by robotics controllers right here in Houston, and also up in Canada. The teams working in tandem to control the station's robotic arm, the Canadarm2. One of those that was installed was the NICER, the Neutron Star Interior Composition Explorer. And what that's going to be doing is taking a look at neutron stars. Now, neutron stars are some of the most unique bodies in our universe, some of the strangest things out there, and some of the most extreme stars as well. They're extremely dense remnants of very massive stars that have exploded and then collapsed into these spheres that are actually very small, especially if you're familiar with some of the celestial bodies out in the universe. A neutron star typically about the size of New York City, so very small when you think about things, on planetary and stellar scales. But while they're only about the size of New York City, they'll have more mass than our own sun. Which basically gets you into a density to where if you just had 1 teaspoonful of neutron star matter and you had it here on Earth, in Earth's gravity, it would weigh about 1 billion tons. So again, very extreme, very unique stars out there. NICER is actually going to be taking a look at what makes them tick. And one of the really interesting things it's going to be looking at, though, is a form of a neutron star called a pulsar, which these are neutron stars that are spinning in very, very fast revolutions and then blasting out extreme amounts of X-rays. And so for an observer on Earth or anywhere else in the galaxy, these stars actually appear to pulse. And what NICER is going to be doing is it's going to be testing using these pulsars as a form of intergalactic GPS to see if it could use these pulsars to navigate throughout deep space. And this is something that not necessarily something that we would use when navigating our own stellar neighborhood, but when you start looking at going far, far beyond our own planet or even our own solar system, that is something that could conceivably use. So a little bit of space age technology, but something that we're developing and testing right now on board the International Space Station. One of the other payloads that was just flown up that's going to be there for the long haul is the MUSES. That's the Multiple User System for Earth Sensing Facility. And you'll very quickly see why we use a lot of acronyms here at NASA with a lot of these long names for these payloads. But MUSES is actually going to be a platform for a number of different Earth imaging and Earth sensing devices that can actually be interchanged and changed out by the space station's robotic arm. The station providing a very unique vantage point, passing over the majority of the populated areas on planet Earth, and so hosting a lot of different instruments aimed right back down 250 miles below at the Earth to provide data on climate change, weather patterns, a number of different items. And MUSES is going to be a new platform that'll be open for use by a number of different entities, both commercial and governmental, for different applications, everything ranging from disaster response to general Earth observation to agricultural and land use to air quality, oil and gas exploration, just a number of different items. And MUSES, again, another one of those external payloads that was installed on the International Space Station after that successful delivery from Dragon. And then the third and final payload that was delivered in the trunk was the ROSA, the Rollout Solar Array. And this was a really fascinating study done in partnership with the Air Force Research Laboratory, testing out a new type of solar array. So having a very flexible material that came rolled up and then it unrolled almost like a party favor or a rollout tape. And then the array rolls and snaps open without a motor, so none of this was motorized. It was all stored energy just from the structure of the boom, so it was rolled out, and this was just a basic test of this type of technology. And they completed all of their science objectives in the week that ROSA was deployed on the end of the space station's robotic arm, actually in a position very similar to where we see Dragon right now, achieving all of their primary objectives and all of their secondary objectives as well. ROSA was originally scheduled to be installed back into Dragon's trunk and then disposed of along with the trunk, burning up in the Earth's atmosphere, but the teams hit a snag when doing some of the retractions. They were able to retract the array, actually retracting it 3 different times, but not able to get the latches just right, as they were seeing a little bit of differences in the alignment of the latches, but this is something that had been discussed pre-flight, and they actually ended up jettisoning ROSA from the end of the robotic arm, and it'll be in orbit for a number of months, ultimately burning up in the Earth's atmosphere, but not presenting any danger, obviously, to the International Space Station or to any of the other upcoming visiting vehicles. And again, although that latching didn't work, this is a technology demonstration, so the team's still learning. And the lessons that they learn from that, they're just going to be able to apply to these future designs. And this is just a really great example of all of these different types of technology demonstrations taking place on board the International Space Station, proving these technologies that are going to be used not only on the station, but in different spacecraft of the future as we look to explore even further beyond our own orbit.
Thank you.
So right now we are just about 19 minutes and counting from the opening of the release window. And again, once that release window is open, the crew can give the command to release Dragon. It'll take about a minute or so. Once the command is given for Dragon to actually be released, as a series of snares in the robotic arm execute and then release their grasp on the Dragon spacecraft. Pretty soon, Flight Director Dina Cantella going to go around the room, get a final go, no-go from the teams here in Mission Control Houston, radio that up to the astronauts waiting on board, Jack Fisher and Peggy Whitson inside the cupola at the robotics workstation. And then we'll continue to just stand by for the next couple of minutes till that release window opens and we get to see Dragon depart the International Space Station.
Did you want monitor 2 or monitor 1?
We'll take monitor 1, Peggy.
How does that view look?
And we're working on the routing right now. I'll let you know when we get it up.
All right, sounds good.
And Peggy, while we're getting that video routed, you have a go for Dragon configuration checks. Please perform step 1 in 1.602, Dragon departure monitoring.
Step 1 in 1.602, departure monitoring.
Again, continuing to get some pretty spectacular views of Dragon. This one actually from one of the newly installed HD cameras on the outside of the International Space Station. We're just under 15 minutes, actually 14 minutes, 42 seconds and counting away from the opening of the release window, at which point the crew will get the go to trigger the release of Dragon. Again, though, the teams here in Mission Control Houston will be going around the horn soon to get a final go, no-go for the departure, and that'll be communicated up via Capcom to the Expedition 52 crew members on the International Space Station. So we'll stand by and just follow along and continue to get a few more great views of Dragon while it's still attached to the Canadarm2 and its mission still at the International Space Station.
Houston Station on 2. The dragging is providing LiDAR filter data from LiDAR 1, and light and CCP LED status are as expected.
So this actually a view from a camcorder inside the cupola. So this is actually what Jack Fisher and Peggy Whitson are seeing right now inside that cupola window. And they're standing by again at the robotic workstation inside the windowed module for them to ultimately give the command to the Canadarm, to robotic arm, to release Dragon. And that release expected to come at about 1:41 a.m. Central Time. Spectacular blue ocean backdropping the Dragon spacecraft, the International Space Station actually just passing over the South China Sea, about to continue on this southeasterly track, eventually crossing over Indonesia and then over much of Australia before heading into an orbital nighttime. We're just a little over 10 minutes away from the opening of the release window. The teams here in Mission Control Houston go for departure, so we'll again just kind of continue to stand by here as we gear up to say farewell to Dragon. Jack Fisher and Peggy Whitson standing inside the cupola. They'll be the ones ultimately giving the command to release Dragon and send it on its way back home. And we are now 8 minutes and counting from the opening of the release window. Again, the window is going to open up at 1:40 a.m. Central Time. The departure expected to come around 1:41 a.m. It's because once the command sent, it takes about a minute or so before the robotic arm will actually release Dragon. But that departure could come anytime inside of the release window. It'll open up at 1:40 and it'll close at 2:05. In the event that they don't get Dragon off during this first release window, there is a backup window, but everything proceeding very smoothly so far this morning. Looking forward to an on-time release. And we are now under 5 minutes away from the opening of that release window. SpaceX Dragon, the CRS-11 commercial resupply mission, the 11th for SpaceX, getting ready to depart the International Space Station.
Station Houston on 2 for Dragon.
Go ahead on 2 for Dragon.
Okay, Peggy, we are looking good down here. You have a go for Dragon release on time. Perform steps 2 to 4 in 1.320 Dragon release. Your release window opens at 0640.
Go for step 2 and subsequent in procedure 1.320. Release window open at 0640.
Correction on the time, Peggy, and just to clarify, that's steps 2 through 4.
2 through 4 for steps in 1.320.
Good readback.
So we are just under 3 minutes away from the opening of that release window. You heard 0640, the station, and all the control teams around the globe operating on Greenwich Mean Time. So 6:40 in the morning for the crew on board the International Space Station is the opening of the release window. It'll be 1:40 a.m. here in Houston, 2:40 a.m. on the East Coast. The International Space Station is still a little over 255 statute miles, and it's just now crossing over Australia, so you should be treated to some pretty spectacular sights on the ground there as it crosses over the Northern Territory and then eventually swings out, crossing back over the ocean just to the south of Sydney. But we are just a little over 2 minutes away from the open of the release window. Again, once that release window opens, the crew will have the go to send the command to the Canadarm2 robotic arm to release Dragon. It'll take about a minute after the command is sent for Dragon to detach. It'll float away a short distance and then execute a series of 3 burns to begin taking it away from the International Space Station. Under 1 minute from the open of the release window. With that 1:40 a.m. Central, the release window is now open. So with the window open, we'll stand by for the issuance of the command to release Dragon from Canadarm2. And once the command's given, it takes a little while for the snares to retract and Dragon to be released, and then it'll slowly drift away. Getting the confirmation the snare's open. And as you can see, slowly moving away, Dragon released. And so the robotic arm now being backed away by the crew on board, and the release coming on time at 1:41 a.m. Central, while the station was a little over 258 statute miles over the central part of Australia. So they're now going to back the arm away, and then a series of 3 burns will be executed using thrusters on Dragon to begin taking it away from the International Space Station. Getting a good view right down the barrel of the robotic arm. You can see it continuing to back away. And the first departure burn has begun.
In Houston Station, Dragon depart was commanded, and we see VV mode departure.
Houston copies. Station, departure burn 1 is complete. Departure burn 2 in approximately 1 minute.
So the first departure burn good and in the books. The second one queued up next, taking place in just under a minute. That second departure burn will begin moving Dragon even further away from the International Space Station, setting it up for the third and final departure burn, which will eventually carry it out of what's known as the keep out sphere and the approach ellipsoid. These are basically distances around the International Space Station that govern interactions between the station and any other visiting vehicle approaching or leaving the orbiting complex. The visiting vehicle officer confirming the second departure burn has begun.
Station Houston, departure burn 2 is complete. Go for SSRMS safing. Perform step 5 in 1.320. You can expect departure burn 3 in approximately 7 minutes. Monitor per step 3 in 1.602.
Copy. Go for step 5 in 1.320, and monitoring step 3 in 1.602.
Good words, Peggy.
So Dragon continuing to fly away, the distance between it and the International Space Station to which it had been attached to for the last month continuing to widen. It'll have one more departure burn to finally get it out of the station's neighborhood and well on its way back for an eventual deorbit through the Earth's atmosphere. And SpaceX's Dragon, the only cargo ship currently capable of returning hardware back down to Earth through a splashdown into the Pacific Ocean. It's packed with over 4,100 pounds of vehicle hardware and science experiments and other items from the International Space Station.
We'd like to say just a couple words for our friend that we just said goodbye to. Dragon's been an incredible spacecraft. I could even say it was slathered in awesome sauce. This baby has had almost no problems, which is an incredible feat considering it's the first reuse of a Dragon vehicle. And the science we've done, oh my, the science. Most of the 6,000 pounds of cargo carried was science, and almost all the return cargo are precious samples for discoveries we can't wait to see. In addition, Dragon brought up a host of external experiments. We've added an external platform for science, a neutron star analyzer, and a new solar array that rolled out like a party horn on New Year's Eve. The science of this mission has been nonstop, and we think the scientists will be extremely happy with the volumes of data we gathered for them up here in space in our floating world-class laboratory we call home. There are thousands across the world to thank, but a few big ones at SpaceX, Brian Coffey, Sarah Walker, and Artie Matthews, and at home in Houston, Kelly Holloman, Joey Crawford, Matt Wilkinson, Ryan East, Cal Brogdon, and my buddy Dina Cantella, who put it all together. But really, for the whole SpaceX team, thank you for building us such a great vehicle and for finding us some good weather today to allow us to bring home the science on time. And for the worldwide team that makes our daily search for discoveries possible, thanks for letting us play a small role. Godspeed, air wins, Dragon 11.
Houston copies, and Two Fish and Peggy, nice words on behalf of the SpaceX and NASA team. Thanks for all of your hard work. It would have been possible without you.
Some eloquent words from the King of Awesome himself, NASA astronaut Jack Fisher, as both he and Peggy Whitson say farewell to the Dragon spacecraft, which a lot of the cargo on board has consumed their lives for the last month as they burn through thousands of pounds and dozens of different science experiments, many of which now making their way back down towards Earth, which you can see now shrouded in darkness. The International Space Station and Dragon just passing into an orbital nighttime, just crossing the Terminator line, that line between night and day on the Earth's surface. Dragon continuing to depart the area from the International Space Station. Coming up will be that third and final departure burn. We'll stick with it until it's out of the approach ellipsoid, that area around the station where vehicles coming and going from the station are closely watched and worked with the teams here in Mission Control Houston, but everything going very smoothly. An on-time release of Dragon at 1:41 a.m. Central Time, 2:41 a.m. Eastern, while both Dragon and the station were flying just over the central part of Australia. This, of course, setting it up for a splashdown in the Pacific, about 260 miles to the southwest of California. The splashdown time was pegged to be approximately 7:41 a.m. Central Time, so just about 6 hours exactly after the release, but that could, of course, change over the course of the next several hours. But that's the target time. It'll be 5:41 in the morning over on the West Coast in California, where teams from SpaceX will be standing by to pluck Dragon out of the ocean, get it on a boat, and get it back into harbor to begin unloading all of that cargo on board. Again, a little over 4,100 pounds packed inside of the pressurized Dragon module, which will, in just a couple of hours, be making the plunge through the Earth's atmosphere. The heat shield protecting all of that critical cargo on board from the heat of re-entry, getting it down to a parachute-assisted landing in the Pacific Ocean for retrieval and delivery back to the coast. But everything going smoothly with this morning's operation. We'll just watch for a few more minutes while Dragon heads off into the black. Everything going very well with the end of this SpaceX's 11th commercial resupply mission. Getting confirmation the third and final departure burn has begun. Again, this just to continue getting Dragon out of the area of the International Space Station, putting it into its eventual deorbit attitude and deorbit positioning. That splashdown scheduled to come a little under 6 hours from now. Splashdown into the Pacific, where Dragon will get picked up by teams from SpaceX, but the third and final departure burn underway. Dragon soon will be out of the keep-out sphere and the approach ellipsoid and on its way back to the Earth.
Burn 3 is complete. Dragon is outside the keep-out sphere.
Station copies.
So again, Dragon now out of the keep-out sphere. All 3 departure burns completed. We'll stick with it for just a few more minutes until it's out of that approach ellipsoid, and then we'll go ahead and say farewell. But everything gone by the book so far this morning. Dragon, which over the last several weeks has been packed with cargo and science samples bound for labs back down here on planet Earth. Over 4,100 pounds of stuff just inside of that Dragon module, going to be splashing down in the Pacific Ocean in just a couple of hours' time. It was the hatch was closed back on Saturday. Dragon itself was detached from the Harmony module, where it's been since June 5th. Just yesterday by teams here in Mission Control, and put into its release attitude, so its release positioning. And then Peggy Whitson and Jack Fisher inside the cupola, giving the command on time at 7:41 a.m. Central Time, 8:41 a.m. Eastern, while the station was flying just over the central part of Australia and sending Dragon on its way. All 3 departure burns have gone flawlessly so far. It should be out of this approach ellipsoid in the next 3 or 4 minutes, and then Dragon will be well on its way. Again, for now, we're just standing by. Just a few more moments. Should be hearing soon that Dragon is out of that approach ellipsoid, that area around the station, just signifying that it is outside of the station's immediate neighborhood and on its way towards its eventual splashdown. Should be hearing that momentarily. And there we hear it. The visiting vehicle officer confirmed Dragon outside the approach ellipsoid. It's release successful. It's on its way now towards that splashdown. Just to recap for you, SpaceX's Dragon, the CRS-11 mission, the 11th resupply mission for SpaceX, released at 1:41 a.m. Central Time, 2:41 a.m. Eastern Time, with 4,100 pounds of cargo on board. That release coming while the station flew just over Central Australia.
On 2, Dragon is outside the approach ellipsoid on a safe 24-hour free drift trajectory.
Station copies. Thanks for this update.
But with that Dragon now on its way, the splashdown scheduled around 7:41 a.m. Central Time, 8:41 a.m. Eastern, in the Pacific Ocean, about 260 miles southwest of California. Dragon will splash down, get picked up by a boat with SpaceX engineers on board, get brought back to port, and all of that cargo will get unloaded, with a lot of it being turned over immediately to get back in the hands of researchers down here on planet Earth to continue the research on their different experiments. But a successful mission for Dragon, splashdown up next, and then its mission will be at an end. But that's going to end our coverage today. I want to thank you for either staying up or waking up or tuning in, depending on where you are on planet Earth, and watching as we said farewell to this Dragon vehicle this morning. But with that, we are going to go ahead and end our coverage today. This is Mission Control Houston.